Dear students, now I am going to explain about stress analysis of rectangle plate with circular hole. Here in the problem, in the plate with a rectangle plate with a circular hole under plane stress condition, find the deformed shape of the hole and determine the maximum stress distribution around this circular hole along AB. Okay, uh, you may use T is equal to 1 mm, thickness as 1 mm, and Young's modulus as 210 GPa, and point ratio as 0.3. Diameter of the circular hole is 10 mm. Here assumption is plane stress with thickness is considered. You can see the dimension of the rectangle plate 60 mm width and 40 mm height. The diameter of circular hole is 10 mm, and this rectangle plate is acted upon by 2000 Newton on both the sides of the plate. And we can analyze this problem by using ANSYS. So here our preference should be structural. Click OK, and preprocessor. In the preprocessor we need to select the element type of element, go to add, delete, and add. Here I am going to take solid as our element. In the solid, but specifically quad 4 node 182. Click OK. In the options, element behavior, this is plane stress with thickness. It's already defined in the question, plane stress with thickness. Close it. Then real constant. In the real constant, add the thickness, add, edit, add, click OK. Here THK thickness is 1, click OK, just close it. Then in the material properties, material models, here I am maintaining the same unit. If you use mm, you have to use mm throughout the analysis. If you use meter, you have to use meter throughout the problem analysis. Okay, so here already I have given thickness T is equal to 1 mm in a real constant, so Young's modulus also should be in mm. So linear, structural, linear, elastic, and isotropic material property is same in all direction, so it should be 2.1 e power 5, and Poisson ratio is 0.3. it is given the question. Then close it. Material properties over. Then go to modeling. How to create the areas. So rectangle by dimensions. See the dimensions here. This is x1 y1 coordinates. X1 y1 is in 0 0 coordinate, right? Where is x2? X2 is 60 mm distance. Where is y2? 40 mm. So x1 y1 is 0, x2 is 60, y2 is 40. So here by dimensions, this is x1, this is y1. x1 is 0, y1 is also 0, x2 is at 60, y2 is at 40 distance. Click OK. Rectangle, and we have hole, right? Yes, go to, and this hole is at a distance of 30 mm along x-axis and 20 mm along y-axis. And what is the radius of this hole? Dia is 10, radius is 5. Along x 30, along y 20. 30, 20, radius is 5. So now is under create, go to circle, solid circle. Okay, along x it is 30, along y it is 20, and radius is 5. Okay, we have created a circle, but I need to punch out or cut out this circle. So instead of this create, we have one more option, operate. In the operate we have Boolean operations. We have several operations, and under that we need to subtract, right? Subtract the areas. Yes. So here I need to select the base area. First I need to select the base area. So this is a rectangle with the base area. Select the base area. So click OK. Okay, if pink is highlighted, then it is selected. Click OK. Then OK. Once again it's asking, so area we have to subtract. Area we have to subtract. This circle we have to subtract, right? Select it. Now it is selecting entire area, but I need circle has to be selected. Click next. Now only circle is selected, right? Just click OK. OK. Yes. The next step, meshing, modeling over meshing. go to mesh tool, and next here check mesh areas quad free. Okay, mesh it, pick all, close it. Now we got the coarse mesh. Means area mesh area elements are more, right? Area of the element are more. I need fine mesh. What to do? Go to mesh tool. Here we have one more option, refine. Pick all. Refinement you can take 2 or 3. Here I am going to take 3. Click OK. Close it. Now we got the finer mesh, and also even finer around the hole. Okay. Raise it. Yes. Just close it. And meshing over, then apply loads, define loads, apply structural loads. Here in ANSYS I cannot give the loads on both sides of the plate. One side has to give constraint, other side I can apply load. So here one side I will apply displacement, zero displacement means constraint. Displacement on nodes, you can use box option, not single, box, and rectangular selection on the left side. Okay, so this side should be zero displacement, means all degrees of freedom should be 0. Okay, 0. Click OK. And displacement over. Next, force and movement. Right side I am going to apply force on nodes. Select the box option and rectangular selection on the right side. Okay, so all the nodes are selected. Click OK. What is the load is given? 2000 is given. 2000 in this side, 2000 in this side is constraint. 2000 Newton, positive x direction. So our nodes selected. Click OK. 2000. So loads over. Next, solution, solve, current LS, click OK. Solution is done. Close it. So we solved it, but I need to plot the results. Go to general processor, and that plot results, contour plot, nodal solution. First question aim is I need to see the displacement or deformation. Displacement vector sum of all the vectors, displacement vector. It's a deformation plot. If you want stress, go to same nodal solution, stress, take warm stress, click OK, and check the stress concentration around the whole, and maximum stress and minimum stress. Thank you.